the last thing that we can do here is to evaluate for the things that we know are true for this situation. Okay? So in order to do that, what we're going to do is we're going to take into account that we know that this block is going to be at rest. So if the block is at rest, that means the velocity is not changing, which means the acceleration is going to be 0. And so that's to say that this is equal to 0, this is equal to 0, right? It's not accelerating the x direction, it's not accelerating the y direction. So that gives us, for our step 6, this is going to give us some equations that we can solve here. So this says that 0 is equal to mg times sine of theta minus f, and 0 is going to be equal to n minus mg cosine of theta. Now, from these two equations, we can rearrange this in order to write what our force of friction is and write what our normal force is going to be. And so really, there's kind of a step 7, and that's once we've set up these equations, we can solve for what it is that we're ultimately looking for. And solving these equations says that this is going to be F, the force of friction, is going to be equal to mg sine of theta, and the normal force is going to be equal to mg cosine of theta. Now, I was a little bit careless with the way that I was defining the force of friction previously in this sequence of videos. And this is the way that you want to do this. You want to say that the force of friction is just some f, some lowercase f. And that's going to be equal to, in this case, the mg sine of theta. But the reason why you do this is because the force of friction is not always the coefficient of friction times the normal force. This is the maximum value that it can have. Okay? So this is the answer to the first question that I was asking. What is the force of friction? Well, the force of friction just has to directly oppose the force of gravity that's in this case parallel to the plane. So this is the general solution. But then we can consider, well, what's the maximum value that the force of friction can have if this is not going to slide down the plane? And considering that maximum, and really when we're writing our force of friction, this is going to be less than or equal to the normal, mu times the normal force, where mu is a coefficient of friction. At a maximum, this can have a value of F is equal to mu times n. And so that's to say, at a maximum, the force of friction is equal to mu times n. So F is equal to mu times n, which in this case we've determined was going to be mu mg cosine of theta. So this is like our max force of friction. Okay, so that's going to be it for this one. We're going to have a more open-ended question after this, now that we've kind of built up all of these ideas.